Imagine cutting through metal as easily as slicing through butter. This might sound like a scene from a science fiction movie, but it's a reality thanks to a groundbreaking technology. Picture a world where the toughest materials are effortlessly shaped and molded with unparalleled precision. This is not just a dream, it's the power of Wire EDM. No, it's not magic, it's Wire EDM. Wire Electrical Discharge Machining, or Wire EDM for short, is a process that has revolutionized the manufacturing industry. It allows us to achieve feats that were once thought impossible. Imagine the ability to cut through metal with the same ease as slicing through a loaf of bread. This is the magic of Wire EDM. Wire EDM stands for Wire Electrical Discharge Machining. This technology uses a thin, electrically charged wire to cut through conductive materials. The wire never actually touches the material. Instead, it creates a series of rapid electrical discharges that erode the material away. This allows for incredibly precise cuts and intricate designs that would be impossible with traditional machining methods. It's a revolutionary technology that has transformed the way we manufacture intricate parts. From the smallest components in electronic devices to the most complex parts in aerospace engineering, Wire EDM has made it possible to create designs that were once only imaginable. The precision and accuracy of this process are unmatched, making it an essential tool in modern manufacturing. This incredible process uses an electrically charged wire to cut through conductive materials with incredible precision. The wire is guided along a predetermined path, allowing for the creation of complex shapes and intricate patterns. The level of detail that can be achieved with Wire EDM is truly astonishing, making it the go-to choice for industries that require high precision and accuracy. Wire EDM has become indispensable in various industries, from aerospace and automotive to medical and electronics. In the aerospace industry, it is used to create critical components that must withstand extreme conditions. In the automotive industry, it allows for the production of high-performance parts with tight tolerances. In the medical field, it is used to manufacture intricate surgical instruments and implants. And in the electronics industry, it enables the creation of tiny, precise components that are essential for modern devices. Its ability to create complex shapes and achieve extremely tight tolerances makes it the go-to choice for demanding applications. Whether it's creating intricate molds for plastic injection molding or producing precision gears for high-performance machinery, Wire EDM delivers results that are simply unattainable with other methods. The precision and versatility of this technology have made it a cornerstone of modern manufacturing. In this comprehensive guide, we'll delve into the fascinating world of Wire EDM and explore its intricacies. We'll take a closer look at how this technology works, the various applications it is used for, and the incredible benefits it offers. Whether you're a seasoned professional or just curious about the world of manufacturing, this guide will provide you with a deeper understanding of Wire EDM and its transformative impact on the industry. So let's embark on this journey and discover the magic of Wire EDM together. At its core, Wire EDM operates on the principle of electrical discharge machining. This process is a marvel of modern engineering, allowing for incredibly precise cuts and intricate designs that would be impossible with traditional machining methods. The key to understanding Wire EDM lies in grasping the concept of electrical discharge machining itself. Essentially, it involves using electrical energy to erode material from a workpiece, rather than cutting it with a physical tool. This method is particularly useful for working with hard metals and complex shapes. Imagine a tiny lightning bolt jumping between 2 points. This is the essence of electrical discharge machining. The lightning bolt is actually a spark generated by an electrical discharge. This spark is powerful enough to erode the material it contacts, but it is also controlled and precise, allowing for detailed and accurate machining. This is essentially what happens in Wire EDM, but on a much smaller scale. The process is highly controlled, with the wire moving in a precise path to create the desired shape. The wire itself is incredibly thin, often just a fraction of a millimeter in diameter, which allows for very fine cuts and intricate details. A thin, electrically charged wire acts as the tool. This wire is continuously fed from a spool, ensuring that it remains fresh and effective throughout the machining process. The wire is made of a conductive material, such as brass or copper, which allows it to carry the electrical current needed to generate the sparks. It never actually touches the workpiece. Instead, The wire is positioned very close to the workpiece, with a small gap between them. This gap is where the electrical discharge occurs, creating the sparks that erode the material. Instead, the wire and the workpiece are submerged in a dielectric fluid, which acts as an insulator. This fluid is crucial to the process, as it helps to control the electrical discharge and cool the workpiece. It also flushes away the eroded particles, preventing them from interfering with the machining process. As the wire approaches the workpiece, a controlled electrical spark jumps the gap. This spark is generated by a high-frequency electrical pulse, which creates a small but intense burst of energy. The energy from the spark is enough to vaporize a tiny amount of material from the workpiece, creating a small crater. This spark erodes the material, creating a precise cut. The process is repeated thousands of times per second, with each spark removing a tiny amount of material. This allows for very fine and detailed cuts, with a high degree of accuracy and precision. The continuous movement of the wire and the flushing action of the dielectric fluid remove the eroded particles, ensuring a clean and accurate cut. The wire moves in a precise path, guided by a computer-controlled system, which allows for complex shapes and intricate designs to be created. The dielectric fluid also helps to cool the workpiece, preventing it from overheating and ensuring a high-quality finish. This combination of electrical discharge, precise wire movement, and effective particle removal makes wire EDM a powerful tool for modern manufacturing. A typical wire EDM machine comprises several key components, each playing a crucial role in the precision and efficiency of the cutting process. Understanding these components helps us appreciate the complexity and sophistication of this remarkable technology. First, we have the wire spool, which holds the thin wire, typically made of brass or molybdenum. This wire is the cutting tool of the machine, and its quality directly impacts the accuracy of the cuts. The wire is continuously fed from the spool, ensuring a fresh cutting edge is always in contact with the workpiece. The wire is threaded through a series of guides and tensioning devices. These guides are meticulously designed to maintain the wire's alignment and tension throughout the cutting process. Proper tensioning is critical as it prevents the wire from sagging or breaking, which could compromise the precision of the cut. This ensures its straightness and optimal cutting performance. The straightness of the wire is vital because any deviation can lead to inaccuracies in the cut. The tensioning devices work in harmony with the guides to keep the wire perfectly straight, allowing for precise and consistent cuts. Next, we have the work table, where the workpiece is securely mounted. The work table is designed to hold the workpiece firmly in place, preventing any movement that could affect the cutting accuracy. The stability of the workpiece is essential for achieving the desired dimensions and surface finish. The work table can move in multiple axes, allowing for complex cuts. This multi-axis movement is controlled with high precision, enabling the machine to create intricate shapes and patterns. The ability to move in various directions makes the Wire EDM machine versatile and capable of handling a wide range of cutting tasks. The dielectric system circulates the dielectric fluid, usually deionized water. This fluid serves several purposes. It cools the wire and the workpiece, flushes away debris from the cutting area, and acts as an insulator to prevent short circuits. The quality and flow rate of the dielectric fluid are crucial for maintaining the cutting efficiency and accuracy. Finally, the machine's computer control system governs all aspects of the process, from wire speed and voltage to cutting path and accuracy. This sophisticated control system allows for precise adjustments and real-time monitoring, ensuring that the cutting process is optimized for each specific task. The integration of advanced software and hardware makes the Wire EDM machine a powerful tool for modern manufacturing. Wire EDM's versatility has led to its widespread adoption across a wide range of industries. In aerospace, it's used to manufacture intricate turbine blades and engine components. The automotive industry relies on Wire EDM to create complex molds and dies for plastic and metal parts. In the medical field, Wire EDM plays a crucial role in producing surgical instruments, implants, and dental tools. Its ability to machine biocompatible materials with high precision makes it ideal for these applications. Other industries, such as electronics, tool and die making, and even jewelry design, also benefit from the unique capabilities of Wire EDM.